Here we go. I don't speak Portuguese, so it's going to be quite easy to figure out what to say. So, apparently, I'm going to discuss and talk to you about programação orientada a gambiarra, and I don't know what gambiarra is. So, I only see that there is Inferno there. Probably that's going to be what I feel right now. So, that talk originally was from this cool guy that hopefully I will meet one day. I'm Antonio from Spain. I have lived in France and now in UK. 18 years starting as a Java developer. So I know a little bit about Java, not to be a Java leader as that person. So hopefully you are not going to be bored today. Let's see how it goes now. So someone said that Ricardo did the slides. I need to find Ricardo after the talk. We're going to have a discussion probably in a Latin way, man-to-man. So the thing is, one of the key things for me being here, I'm afraid of public speaking, and I'm always trying to change myself and try to explain that even when the unexpected happens, you can learn a lot. The thing is, if you get out of your comfort zone, you're going to become better every day. I need to go a little bit freestyle because I don't actually understand anything what is written there. But it doesn't matter. You need to check more or less what the history of the subject that you want to talk. So Karaoke Ignite Talks, the history, the first time that I heard about that, it was 2 or 3 years ago. Chris Wittard, one of the creators of DevOpsDays, actually proposed to do a Karaoke Ignite Talk. And I didn't step up at that time because I was already doing one Ignite Talk. But I say, yeah, afraid of public speaking, asthmatic, my accent is really, really bad. Let's try it. I did it once in Warsaw, and they also put a talk of someone else from Poland. Of course, I don't speak Polish either. So it was more or less the same feeling as now, a lot of people having fun, that I think is one of the key things of the conference, is everybody having fun. Even me here, I'm actually having fun. There is one thing that I spotted on the last ausencia of coffee. That's the worst thing that could ever happen to me. I don't have blood, I have coffee. So if you want to get better, you need to embrace change, reflect more or less why you want to change, think more or less how redirect your thoughts, and trying all the time. And probably you would get a little bit better. Of course, it's not easy. Life is not easy. And life is not easy for a speaker. But try at least to document what you're doing and try to figure out if your company is going to get money or not about what you're doing. Because probably if you're not going to do it, you're going to get fired. Okay, so I'm only spotting only some words. So in order to be here, you need to have a good determination and forget about the feeling of being ridiculous or things like that. That was more or less one of my fears when I started being on stage. And actually, the worst thing that could happen, it's today, and it's not that worse, because I'm having fun, and it's only 1 more minute of suffering for everybody. So some techniques for giving talks like that. When it's a talk that you actually know the slides, it's easier, because you are the only one knowing the slides, so you can say whatever you want. That the public, they cannot say, no, that's not right, because it's your slide. Here is more or less the same, because I don't know what it's saying, but it's the talk today. So, patching and debugging. So that's something important to do, probably also with the slides like that. There are a lot of bugs here, and we should debug on the next time that someone proposes a Karaoke Ignite talk, and to do it a little bit, maybe one image from time to time, incremental amount of images. But don't be afraid to be here. Propose talks for the next DevOpsDays Portugal. The experience is really amazing, and we want your experience to be here on the stage. Thank you very much.
All right. Okay, so I'm going very briefly to tell you how you can shave off milliseconds of your distributed application or your distributed data store. Let's take a very quick example. So Redis, everyone probably uses it sometime here or there. And Redis has a very simple web interface that you can put on top of it. It's called WebDis. And it basically gives you an API to set values and get values. What I'm going to do is I'm going to deploy Redis on an unusual place, the US East Coast, which is the cheapest region I know. And I'm going to serve my customers all over the world from that region. So what do we get? For example, my poor customers in Singapore will have a response time of 436 milliseconds. And on the rest of the slide, if you can see it, you'll see the response time of everywhere else around the world. So this is quite easy, quite fast to do, but some of the customers will probably not be very happy about that response time. Now let's try and do it differently. I have the container. I can just deploy that container all over the world if I have an infrastructure for that. And that's exactly what I'm going to do. I'm going to take that container that I built initially, and I'm going to deploy it on all 5 continents in multiple locations in those continents. Just wait for the container to start everywhere. So we have the container running on all those locations. So Amsterdam, Toronto, Melbourne, São Paulo, Warsaw, Hong Kong, Singapore, Los Angeles, and so on. I also have an Anycast IP address for all of these locations. So depending on where my customers are, I can actually give them one IP address, or at least put that IP address on my DNS records, of course. And they'll automatically will be routed to the closest POP. So let's see what happens. So the exact same data is now retrieved by my Singapore customers with a 2 millisecond latency. How is this possible? Is the data the same? No, the data is not the same. So this uses a very interesting feature of Redis, which is replication. And you can just start replication like this. So we had our master node in the US East Coast. We launched all the containers. We got the IPs of all those containers. We logged into the master node, started replication with that, and the data is replicated across the entire world. And that's how you get the same data in Singapore that you set in the US East Coast. And how does this happen? It happens because we just deployed this container exactly to the edge. And what is the edge of the internet? The edge of the internet is the device that's closer to the user. So in this case, our container is probably running right next door to that particular user. In our case here, it could be running in a Lisbon data center. It could actually be running in the cell tower closer to this building. So that's why you get such a low latency. And what kind of edges we may have. So we have the typical cloud edge of the typical providers. Then we have the exchanges edge, if you want to call it that way, and that's where typically these containers run. And then we even have closer edges to the users, like the example that I was giving before was running this in the cell tower next to this building. And this is the power of edge computing. So we all know the origin computing, so deploying whatever we want in one of the cloud providers, and that's our origin. That was my US East Coast. Edge computing is exactly this. So I move my containers to closer to the user and giving them faster response times while sharing the same data, of course. And that was it. 30 seconds to spare. So if you guys want to see this working, meet me afterwards, because in 30 seconds I don't have time to show you a demo.
What's going on? My name's Daniel. I work for a company called Datadog, and I have a confession. I'm obsessed with time. And with measuring time, with measuring things in general, really. So we're going to spend a little bit of time today talking about time. First question, what is time? Answer, it's complicated. In fact, a lot of people who are much smarter than I am have spent a lot more time thinking about how to define time. Take, for example, the ancient Greeks. They had 2 words for time, chronos, which is chronological time, as we might understand today, and kairos, which was the opportune or correct moment for an event to occur. In other words, for the ancient Greeks, time was both quantitative and qualitative in nature. Then along comes St. Augustine, preeminent medieval philosopher, tries to define time, ultimately goes mad, says that time is a distension of the mind, made up of our memory of the past, our perception of the present, and our expectation of the future. In other words, time is completely in our heads. Then along comes Newton, rejects that entirely, and says, nope, time is a physical thing, is it a dimension? We can travel across it, and we can move through it, and it's out there, and it's a real thing, but we can only reason about it and think about it as a function of pure mathematics. In other words, time is both physical and mathematical in nature. Then along comes Leibniz and Kant. They reject that and go, nope, time, you can't really measure it directly. It's not quite a physical thing. Instead, we have to use the language of spatial relationships to talk about the distances between objects and events. And then by comparing those measurements together, we can form models to explain buses and the motions of the heavens. Now, this is interesting because it's the first time that we talk about time as a function of both space and time. Space, time. Where have we seen those 2 things together? Space-time, of course. The stuff of Star Trek and first-year physics students is made famous by Einstein's special and general relativities, in which he basically posited that time is about the observer, and about that observer's perception, and about that observer's relationship to the very mathematics that power the universe. Verse. This is where you clap. Time is hard to define. And I got to be honest with you, on the day-to-day basis, it's useless to try to define it. Instead, let's talk about some abstractions. We use abstractions every single day when we talk about time, whether we know it or not. A fairly common abstraction are clocks. Who here has seen a clock? Anybody? Clocks? Yeah. Interesting thing about clocks is in the world of modern physics, time is operationally defined as what a clock reads. So if you ask a physicist, hey, Mr. Physicist, or Mrs. Physicist, or physicist, what is time? They'll say, look at your watch. Calendars are an interesting abstraction because they use the language of spatial relations to talk about time. For example, what is the distance between the 1st of January and the 1st of December? The answer is actually quite a bit more difficult than you might think. Extending that even further, we can talk about time zones. Time zones are cool because they use the language of spatial relations to map space and time directly together. For example, how many hours are there between Sydney and London? Also, time zones are non-Euclidean, so if you're into math, that's actually kind of cool. Extending that even further, we can talk about date-time libraries. Now, date-time libraries pose an interesting philosophical question. If time is at least partly perceptual, and a date-time library is how a computer tells what time it is, can a computer have perception? Word of advice, do not try to write your own date-time library. Beyond the philosophical implications of date-time libraries, they're just incredibly complicated pieces of code. They're very tricky, they're full of spaghetti. It's nothing but debt. In fact, PyTZ, which is the canonical Python library right now, today, has 25 open issues on it, the oldest of which dates back more than 10 years. And R. David Murray, who's a Python language programmer, has this to say about one of them. I wonder if this is by design or by accident. In other words, the people who made it don't understand how it works anymore. Speaking of quotes, you've probably heard this one. Do not assume that the network is reliable. The global NTP network a little while ago suffered a DDoS attack, which made measuring time on the internet substantially more difficult. The reason, by the way, was a Snapchat update, if you can imagine that. That's not the network I want to talk about. Kosovo and Serbia as entities have a history with one another, and that history extends to their electrical networks, which extends to the rest of Europe. And at one point, yeah, I'm over time, it's fine. And at one point, they had a disagreement. And that disagreement caused a minor fluctuation in the distribution of power across the entire European continent. Normally, no one would care, except all clocks that were connected to the power grid began to lose time, as much as 6 minutes in some cases. Now it could be microwave ovens and train stations losing up to 6 minutes of time. The simple fact of the matter is that time is complicated. All right? It has problems. It's tricky, it's finicky, it's hard to understand. But here's the thing. You can't avoid it. It's with us at all times, even if you can't think directly about it. And if you're as obsessed, even marginally as obsessed with time as I am, I'm around for the next couple of days. I'd love to talk to you about it. Once again, my name is Daniel. I work for a company called Datadog. P.S. We're hiring. Thank you very much.
So, how's everybody doing? Everybody still awake? Good. Who is a YAML engineer? Who likes writing YAML? Not so many hands anymore. Let's see how maybe we have to reconsider that today. So, there's this famous paper about go-to considered harmful. And I want to make a proposition basically to say like maybe YAML is to some extent considered harmful because there are various problems to what is in YAML. So why do we have YAML even? First off, it should be human readable. Human readable generally excludes XML because for most of us XML is not human readable. And we had JSON, but JSON is also not very good for humans because, well, no comments in there. And maybe I don't have to shout that much anymore. See? Better? Better? Well, no. Maybe not. I keep shouting. I hope you see the same.
Now. Okay. Okay, no comments in JSON, so that's why we ended up with YAML. But YAML has other properties. For example, white space sensitivity. If you're coming from the Ruby or Python world, you think this is the right approach, that white spaces have meaning. If you're coming from C, Java, .NET, whatever, you think this is the totally wrong approach and white spaces shouldn't have any proper meanings. This is a religious belief. We won't make any final judgment on that today. But anybody knows this might be a Docker Compose file. Anybody knows what might happen if I run that through a YAML linter? And what might be the problem in this one? Has anybody encountered that? So what you will get is this one, because what Docker Compose assumes is that if you have any number with colon 6, and then the number is smaller than 60, it's base that number. So this would be calculated base 20. And that's why you have this very weird number at the bottom one, because that would be considered base 20, and then your number would be totally wrong. And that's why you would need to quote that. Or maybe you have done something like this, where you have a list of countries. And here you can already see the syntax highlighting is helping you out. But this is one of 22 ways to write a Boolean true or false value in YAML. So you have plenty of options there. But maybe this is not really what you wanted. Also, these are some popular examples. So for example, null, this could be evaluated to empty or none. Having a colon in the value without quoting is not allowed. And probably you didn't want the version to be a floating value, but you wanted to have it 1.0 and not a floating value. Yeah. And the general abuse is really when you don't try to have data in YAML, but when you try to codify programming. Because if you want to use a programming language, use a programming language, don't use YAML for that. And I don't want to bash on GitLab in general. It's just I saw this beautiful example they had how to bootstrap GitLab itself in a YAML file. And it's 1,100 lines of YAML, which in itself might be a bit of a problem. But then you look at it, and then you see stuff like this. This is basically a glorious shell script runner, because you run various shell scripts, or you call other shell scripts. For example, that review app.shell, that has another 400 lines of shell script in it. So it's basically just a structure around more structures, making it just more complicated. Or if you're writing Helm templates, you might see stuff like that, and then suddenly you have variables, and you need to care about white space indentation, and you can see that n indent 4 basically means you want to indent that by 4 spaces, but this is not really what you want to write in any YAML file. Like, this is the abuse of how to write configuration. If you want to use a DSL,
just use a DSL. It will make your life much easier than trying to come up with some DSL in YAML and passing it through a YAML parser. Or maybe JSONet, that is, it's not officially supported by Google, but it happens to come out of Google because they also saw this problem. And that's starting to gain some popularity because it's trying to combine the simplicity of JSON, but then add some more needed constructs around JSON without the insanity that might come with the full YAML standard. That's the general idea here. And then you might say, like, well, maybe we want to go back to other data formats, maybe XML. But looking at that XML, maybe you don't really want to write that in the end after all anymore. Or you want to write JSON, but well, no comments. You could have this underscore comment to write comments, but it still doesn't feel perfect. You could say, like, oh, we're going back in time. We'll use ini. Like, anybody still remembers ini? But you didn't have any hierarchy, and you can see I need to cheat with the service at the bottom, like I need to have a server alpha IP and server alpha DAC data center. Like, you need to cheat to make that hierarchy. It's just not built in and it's not going to work out there. You could use TOML, which is kind of trying to keep sanity, but TOML is not whitespace sensitive. So for example, in service, that indentation you have at the end of service, that's just arbitrary. Like, you could use any indentation or none. This is just up to you. So it's trying to solve some problems, but maybe not getting there the full way. Maybe the best standard is from IBM. It's JSON-X, which is JSON representation of XML, which is probably the worst combination of all the worlds. But that's what IBM is really good at, to combine stuff like that and do that. So if you want to have the worst possible data or format for your data, that is the one you might want to look into. And that's it. Maybe you want to consider YAML. Who still wants to write YAML afterwards? Well, it's up to you. Maybe we will find something better in the future. Yeah, I'm Philipp. Thanks for joining. I have a couple of stickers over there. If you want to have any stickers, grab some stickers from me. Thanks for listening.